Hello, so today we're going to go over your scientific notation notes. Please make sure you have that open before we begin. We're just going to go through the notes and go through a little bit of practice with you all. So what is scientific notation, right? Well, in science and math, we often deal with very large or very small numbers. So let's go ahead and put those two words into those blanks. Very large or very small numbers. Scientific notation is a way to write those numbers or these numbers easily in a shorter form. Let's say in a shorter form. Oftentimes this means getting rid of all the zeros in the number. That's normally what we try to get rid of, are the zeros in the number. Okay, so how does scientific notation work? There are always two parts of scientific notation, okay? The factor and the power, okay? So for your factor, which is this part right here, 3.5, right? That's my factor. Notice that I should only have one number in front of the decimal point. I should only have one number in front of the decimal point. That means that my factor is any number, any whole number, or my factor should be any number, right? Any number that is greater than 0, right? So my factor should be any number greater than 0, but less than 10. Okay. And normally what it actually is going to be is that we actually need to say more specifically that your factor needs to be at least 1. Right, so it needs to actually be greater than or equal to 1, but less than 10. Okay, so it has to be a number. It can have a decimal. It doesn't have to have a decimal, but it should only be one number in front of the decimal. And the power, this expresses how many zeros are in the number and can only be in whole numbers. Okay, so this is your power here, and it's usually represented by an exponent. So I'm glad we did our exponent rules first, right? And then that's what we use for our power. So that means that there are 8 more zeros in this number, but it's not really zeros, except it is, in this case, decimal places, because we see that it is a decimal number already. So to write this number in regular form, we need to move that decimal 8 places to the right. So we're actually going to add 7 zeros to that number. So it becomes this number here, which we will read as 350 million. Okay? All right, let's go ahead and do this last point here. So what does scientific notation mean? So in scientific notation, your decimal is where you start from. It is your starting point. You know how many places and which way to move the decimal depending on the sign of your power, right? The sign of the power. So if my power is a positive number like here, or like our first example up here, I'm going to go to the right from my decimal point. If my power is negative, like in this example, I'm going to go to the left. So let's take a look at what that's going to look like. Okay, so in this case, the exponent is positive 8, right? You can write the word positive, or you can just write a plus sign, whatever works for you. Positive 8 means you have to move the decimal point 8 places to the right. I have to go to the right when my exponent is positive. So in all the empty places that I leave after moving from 8 places, I just add zeros, right? And we already know what this number becomes because we did it already, but this number becomes 350 million. So in this case though, on the right here, we see that the exponent is actually negative. That means I have to move the decimal point 8 places to the left. But I'm still going to do the same thing, meaning that I'm still going to put I'm going to fill the empty places with zeros. Okay, but now I have to go 8 places to the left. So I go 1, 2, 3, 4, 5, 6, 7, 8. And I put my decimal point and I fill in all of those places that I jumped with zeros. So that means I'm going to have 7 zeros preceding the 3, or coming before the 3. So I'm going to have 0.00000035. Okay, and I can put a 0 before the decimal point as a placeholder. I don't have to put that 0. This is an optional 0. But I do need all those other zeros now that I've written that number out. So that's why it's much easier to write this number in scientific notation than it is to write it like this, because this is just too many zeros. Okay, so that's how scientific notation works and what it means. What about when we do math with scientific notation? So let's see. How do you multiply and divide with scientific notation? So you can only multiply and divide when all the numbers involved are in scientific notation. So you can only multiply and divide when all numbers involved are in scientific notation. Okay? All right, so now let's get into what we need to do in order to do this math. Okay, so I've erased my screen. So when we multiply and divide, let me just write that back in here real quick. I apologize. When you multiply your decimals, right? Or your numbers that are your factors, and you add your exponents. When you divide the decimals and you subtract the exponents. Okay, so we're gonna give that a try. We're gonna go on to the next page and practice that idea. Okay, so we have a couple examples here, and what we're going to do is we're going to first just see if we can divide them the regular way without using scientific notation. So if we're dividing 0.000006 by 0.03, so of course we have 0.03 on the outside and 0.000006 on the inside. But we have to move our decimal 2 places to the right in order to divide, right? So now my decimal comes up here. So it's actually going to be 3 into 0.0006, right? Move my decimal up, okay? So my answer would be 0.0002. Okay, So what about if we did it in scientific notation? Well, in scientific notation, I'm going to count the number of times I have to move my decimal behind my 6, right? And that would be 1, 2, 3, 4, 5, 6 times. So that becomes 6 times 10 to the negative 6. And here I have to move it 1, 2 times to get it behind a 3. So it's 3 times 10 to the negative 2. Okay, so I have to divide my factors and then subtract my exponents. Okay, so let's divide 6 by 3. When we divide 6 by 3, we get 2. And now I have to do negative 6 minus negative 2, which gives me negative 6 plus 2, which is the same as negative 4. So my answer is 2 times 10 to the negative 4, which is the same answer that I got dividing regularly. Okay, I think it's a little quicker doing it in scientific notation. And so that's why scientific notation is normally used. Let's try it with a multiplication problem. All right, so we have 3,500 times 60,000. So I'm going to be smart about it and try it like this. I'm just going to bring down all of these zeros. That's 3, 4 zeros there. And then I multiply my 6 through. And I'm going to get 210 million. Okay. What about if I tried it with scientific notation? So that would be 3.5 times 10 to the third power, right? Because if I move the decimal from here, 1, 2, 3 to get it behind the 3, times 1, 2, 3, 4 times I have to move it to get it behind the 6. 6 times 10 to the 4. Yeah. So again, I just need to multiply these two numbers and then add my exponents in this case, right? So I know that my answer, so 3 plus 4 is just going to give me 7. So I know it's going to be times 10 to the 7th. And I have to do 3.5 times 6. What's 3.5 times 6? Well, that's going to give me 210 or 21, right? So my answer, 210 because I have my decimal, so it's 21. So I have 21 times 10 to the 7th, right? Or 2.1 times 10 to the 8th, because I can't have 21 as a factor, so just move my decimal over one more time, which means I have to move it over once more over here. And let's see, is that the same as over here? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. It is. It's the exact same. And so that's why scientific notation is preferred. Okay. And so for this last one, we're just going to write it in scientific notation. In this case, we have 7.1 times 10 to the 1, right? Because we don't have to change this number at all. We do have to change this one though. So 1, 2, 3, 4. And we move to the right, so it's going to be a negative. So it's 3 times 10 to the negative 4. And again, we're going to multiply the factors, multiply these two, and then we're going to add the exponents. So 7.1 times 3 gives me 21.3. When I add my exponents, when I add 1 plus a negative 4, it's the same as saying just 1 minus 4, which is going to give me negative 3. So it's 21.3 times 10 to the negative 3. But of course, 21 does not work as a factor. I have to move that decimal over by 1. It means to take away, I have to add, 1 here, which is going to give me 2.13 times 10 to the negative 2. Okay, that's going to be our answer there. You're going to get much quicker with the scientific notation once you practice it. Okay, so I just want you guys to think about it and practice it a little bit. And we're going to just do this one now the reverse way by doing it the regular way of doing 7.1 times 0.0003. So we have 3 times 1, which is 3, 3 times 7, which is 21, right? And I know that I have all of those zeros as well. So I have to move my decimal over 1, 2, 3, 4, 5 times. So 1, 2, 3, 4, 5. So it's 0.00213, which is the exact same as that. Okay, let's keep practicing. So we're going to try these practice problems here. So what is 5.0 times 10 to the 9? So they just want us to change this from scientific notation to regular notation. So we have to move it to the right 9 times because it's the positive 9, right? So we have to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Or in this case, if we ignore the 0.0, let's just pretend it's not there, and we say it's just 5 times 10 to the 9, then we know we just have to add 9 zeros to this number. So it's 5 followed by 9 zeros, which means that it is 5 billion. Okay. Now we want to try for number 2, and we want to write that in scientific notation. So remember, we want a factor that is greater than 1 but less than 10. So we have to move this decimal behind the 8. So how many times does it take us how many moves does it take us to get us behind the 8? It takes us 1, 2, 3, 4, 5. It took us 5 moves and we started on the left. That's a negative move. Okay, so we've moved, that means that we have to, when we move it back, it's going to be negative, right? Because it's moved to the left. So it's going to be 8.4 times 10 to the negative 5. That's how we write that in scientific notation. All right, and now we have another one in scientific notation that they want us to write in standard notation, and it says -3. Whenever the exponent is negative, that means we have to move to the left. So let's move it 1, 2, 3 times. Okay, so we do 0 point and then 1, 2. We have to fill in 2 blanks with zeros. 4, 8, 7. Okay, we have 3 more examples that we're going to do. Okay, so we have this large number here, 30,400,000, which they want us to write in scientific notation. So what we're going to do is, again, we want to make sure that our factor is in between 1 and 10. So that means we have to put our decimal behind the 3. How do we get the decimal behind the 3? How many moves is that? Let's count them. 1, 2, 3, 4, 5, 6, 7. 7 moves. We have to keep all the numbers that are important or significant. So all the numbers that are non-zero and then any zeros in between them. So we have 3.04. Those are our significant numbers because the zeros are not significant, times 10 to the 7, because 7 is how many times we have to move the decimal from the back to get it behind the 3. Okay, all right. And our last one that's in scientific notation, it was to turn into regular notation. We want us to move 4 places to the left because it's a negative. So that's how we know we're going to go to the left. So let's go 4 places to the left. So 1, 2, 3, 4. Okay, it means that I'm going to have 3 zeros before the 5 and the 6. And that's my answer. All right, and the last one is we want to change it to scientific notation from standard notation. So we want this decimal behind the 4. So how many moves is that going to take? It's going to take 1, 2, 3, 4 moves, and we just moved to the right. That means when we change it from scientific notation to standard notation, we must move to the left. And moves to the left are negative moves. So if we have to move it 4 times here, it's going to be 4.95 times 10 to the negative 4. So anytime there are zeros in front of the number, your exponent is going to be negative. Anytime there are zeros behind your number, your exponent is going to be positive, right? This is what we see here. Okay, and your significant figures are any figure or any number that is not 0 and is part of your number. So any number that's not 0 is considered a significant figure, all right? Only time that 0 becomes a significant figure if it's in between 2 other non-zero numbers. So in this case, that's why we have to keep this 0, right? Because we need it to signify that there is a space in between those 2 places here, the 3 and the 4. Okay, so those are your scientific notation notes. There's also a handout on significant figures. Make sure you use both of those things to help you do the exercises. Okay, that is all for me.